All right, students. In an earlier video, we worked on graphing exponential functions. Our next job is to graph logarithmic functions. Let's look at how these two curves are similar to each other. First, I notice that on an exponential function, the x-axis is an asymptote. See how the curve gets closer and closer and closer and closer to it? It'll never touch it. It just keeps getting closer. It'll also never curve away from it. Don't let your curves curve away from the asymptote. They just keep approaching it and getting closer all the time. A logarithmic function also has an asymptote. It's the y-axis. See how the curve keeps getting closer and closer and closer and closer to that y-axis? Never touching it and never curving away from it. The other similarity I see between these two functions are in the numbers. Look at the x and y here and the x and y here. 0, 1, 1, 0. Look here and here. 1, 3 and 3, 1. 2, 9 and 9, 2. See how the x's and y's here are the y's and x's here. That happens when functions are inverse functions of each other, which exponential functions and logarithmic functions are inverse functions of each other. Let's try graphing a logarithmic function. When you do your work, I want you to show me a good graph. Show me an XY chart. The things I write over here are scrap work. Do these in your head if you can. If not, well, scrap paper is the way to go. Let's recall now that f of x is just a fancy name for y. Let's change f of x to y and rewrite the problem as y equals log base 4 of x. Now, since logarithmic equations are inverses of exponential equations, I'm going to switch up my xy chart. Instead of using -2, -1, 0, 1, and 2 for my x's, I'll use them for my y's. Let's use scrap paper to start plugging these in. And I'll plug in the 2 first. If I plug a 2 in for y, then I have to know what x is. Well, remember, this number is the exponent that goes on that 4 and changes it into x. 4 squared is 16. When y is 2, x is 16. Let's try that for 1. We'll take 1 and plug it in for y. Take 1 and plug it in for y. We'll have 1 equals log base 4 of x. Now this 1 is the exponent that goes on that 4 and changes it into x. But 4 to the first is just 4. When y is 1, x is 4. Let y be 0 and plug it in here. And 0 equals log base 4 of x, which means 0 is the exponent that changes 4 into x. Anything to the 0 power, that's 1. When y is -1, I get -1 equals log base 4 of x, which means that -1 is the exponent that changes 4 into x. Negative exponent means reciprocal. 4 to the -1 power is 1/4. Finally, we'll plug in -2 for y, giving me -2 equals log base 4x. -2 is the exponent that goes on that 4. And if I take 4, then square it, then take the reciprocal, that's 1/16. Let's see if we can plot these points. For my y numbers, I've got 1, 2, -1, -2. For my x numbers, when x is 1, y is 0. When x is 4, y is 1. 16,2 is way over here somewhere. 16 to the right and 2 up. Kind of off my graph. Now as x gets close to 0, y drops down to -1. When x is close to 0, y drops down to -1. And when x gets even closer to 0, y is down here at -2. Can you see that the y-axis will be an asymptote? And there's my logarithmic curve. Let's label 2 points. We'll label the x-intercept at 1, 0. This was the point 4, 1. All right, that looks great. Let's try another. I'll rewrite f of x as y equals log base 2 of x. It's a logarithmic function, so I'll choose smart y's and I'll plug them into the function to get x values back. I'm going to start with the 2, plug it in for y there, giving me 2 equals log base 2 of x. Now that's the exponent that goes on that 2 and changes it into x. 2 squared is 4. Got it. Now remember, if you can do these in your head, great. All you have to show on your assignment is the graph and the xy chart. Let's let y be 1 and plug it in for y. Then 1 is the exponent that goes on that 2 and changes it into x. Anything to the first power is just itself. Plug in 0 for y. Then 0 is the exponent that goes on that 2. But anything to the 0 power is 1. When y is -1, then -1 is the exponent that goes on that 2. And 2 to the -1 power just means reciprocal. Finally, we'll let y be -2. Then -2 is the exponent. Darn. Again, my mistakes just disappear. Now, -2 is the exponent that goes on that 2. Two to the -2 power means 2 squared, then reciprocal. 1/4. All right, let's plot our points. My y's are 1, 2, -1, -2. When x is 1, y is 0. When x is 2, y is 1. x2, y1. When x is 4, y is 2. 2, 3, x4, y2. When x gets close to 0, y comes down to -1. x1/2, y -1. And when x gets even closer to 0, y comes down to -2. Let the y-axis be your asymptote. Don't touch it, but get very close to it, and then you curve away. For great credit, we'll label 2 points. All right, that looks great. You go practice a few and then meet me back here.